Great. Well, thanks for being here, and thanks for having me today. Wow, great turnout. I see a lot of friends here too, so it's good to see. Hi, Luke. Good to see everybody here again. Last month, did we have like 8 people? Okay, yeah. So that's probably what I was expecting. I brought about 20 handouts just in case. So obviously, I'm going to make sure I email those or distribute those electronically. But I'm here today, actually not really as a big data expert, so there you go, you came to the big data meetup. I've really been doing like SQL Server development for about 13 years, and the reason I bring that up is hopefully that's maybe an experience you can relate to. Like, I know SQL, but how do I get into big data? How do I get started for free? I know when I kind of looked into getting started, I faced these big 3 questions. And for me, those 3 questions are: 1, how can I get access to a Hadoop cluster if my company doesn't have a dev system for me to play with, or if I don't want to know how to be an admin, maybe I'm not a Linux guru and I can't set up my own cluster, or I just don't want to go through all the steps. Number 2, where do I find big data to analyze? And finally, number 3, if all I know is SQL, do I need to learn a different programming language in order to work with big data? So I definitely want to answer all these questions today. That's kind of the angle I'm coming at it from. Hopefully you can relate a little bit. But before I do that, I want to actually speak to you a little bit about how I think what you already know about relational database systems will help you as you're learning big data. For me, I think when I first started working with databases, this is more how I thought about it. I write select star from my table, maybe a where clause, and I get back this wonderful data set. And that's the great thing that these relational database systems have come to do. They give you this beautiful layer of abstraction, you give it this very standardized query language, and boom, you get back result sets. And for a lot of us, that's what we know, and that's not a bad thing, that's a good thing. But if you really think about what's going on under the hood just a little bit, oops, I went way ahead there. Really what a relational database system is actually a collection of systems, if you think about it. I mean, how many steps have to go on for that magic to happen? It's got to interpret the language that you give it. Then it goes and builds a plan based on the statistics that it has about its internal data. It optimizes that query. It goes and does I/O. It reads off the disk if it needs to, or does it have it cached in memory? It's actually a whole lot of systems working together. And the reason that can be helpful for you is that what big data, I think, is it's a lot of these same challenges that the relational database management systems have been solving for 40 or 50 years almost now, but just done writ large, right? Done in a distributed model. Now, using network externalities instead of shared memory and shared hardware architecture, all these kinds of things. So if you think about it, it's in a way I might kind of group it up like this. Now, instead of storing stuff on the same hard drive or RAID array of hard drives, you've got all these different ways of storing it. Yeah, you can store it on a hard drive. You can stick it in CSV files. You can use HDFS. You can use S3. All different options, ways of sticking all that data into a persistent store. And then there's layers of query and planning and optimization and all kinds of tools for doing that. You've got Hive HivePig, Splunk, Spark, there's a million more. This is my way oversimplified view of the big data world, right? It kind of helped me when I realized that Hadoop isn't just this one thing. It's a whole ecosystem of tools, and in a way, they're trying to solve the same challenges. They're just doing it much larger. And on top of that, you've got kind of that query language. You actually can write SQL against many big data systems. But then you also might need to know Java, Scala, Python, depending on what you're doing. And I kind of wrote Yarn as a resource manager in there in the middle, and also like consistency. I don't know. Does it enforce transactional consistency? Not necessarily. You can depend on your RDBMS to do that if you tell it to. But this is kind of a whole new world, right? You get to kind of roll your own. So with that, I hope that kind of maybe helps you. If you're a relational database person, that's the data you know. Maybe this helps you to say, hey, I'm not starting from scratch. I can learn big data. It may take another peek kind of under the hood for you to kind of get good at it. So let's look at those questions. Number one, how do I get my own cluster? So there's a couple of ways you can do this. One, you definitely can do your own with free infrastructure as a service. The best way I found to do this is using AWS's free tier. So I'd say this is more if you want to kind of learn how to set up a Hadoop cluster. There's quite a bit of work here. In that handout, which I might try to post it on the meetup page or something like that, I have a lot of links provided where you can follow those things. But you have another option. You don't have to roll your own cluster from scratch. You can use some of these managed services, like Azure's managed Hadoop cluster is HD Insight. AWS's is called EMR for Elastic MapReduce. You can totally get those for free, but you have to like fill out a form and wait for them to contact you. So you may not want to mess with that either. The best thing that I found as I kind of dug into this is this group called Databricks, who I think is a lot of the people who wrote Spark, kind of went and formed their own company. And they've got this community edition where literally in like 2 clicks, you can set up a cluster and start writing Spark. So if you kind of just want to get past all the administrative side, I really enjoyed working through that. And I might even show you if we have time just how easy it is. Number 2, where can I find data? It's probably not too hard of a challenge for you, but if you're not familiar, these are some really good data sets right here. Good size. AWS actually provides several public data sets. I didn't realize that before I started digging in. But also down there at the bottom, if you're on the Databricks cluster, they put several data sets kind of out there handy for you to use too. So just one more step that you don't have to go through of digging in and finding all that data. And finally, I had to put a quote in here from someone you probably have heard of. It's our own Mark Smith, that he said last month that you don't actually need big data to learn big data. So, that's, even if you just have a few files, you can still use all of the tools involved in that. And so number 3, do I need to learn another programming language if all I know is SQL? I'm a little biased here, but I'm probably going to say yes. Because as you came to learn SQL, you had the benefit of, again, several decades of standardization and vendors winning out and ANSI standards being implemented and well understood. You don't really have that in the world of big data as it stands today. It's too new, it's too raw. It's more about where consensus is forming in open source communities, right? So But you don't have to become a software developer and learn all these design patterns and things like that. I think you just might want to get familiar with at least one other language. If it were me, I would probably pick Python. I really enjoy using Python. It's just the most universal and multifunctional language. So I'm sure many of you already know another language besides SQL. A lot of what's in the Hadoop ecosystem is written in Java. So if you know that, it's an advantage from what I've heard anyway. I'm actually a .NET guy myself, so learning Python was new to me. But your SQL can still help you, and I kind of wanted to put a little screenshot in there. Like, this is one I actually wrote using Spark. I wrote that you can write that little statement, just tell it that it's SQL. It looks so familiar and comfortable. It gives you rows back. It just gives you this nice, warm, fuzzy feeling, like I did big data with SQL, yay! But it takes some work to get there, and you can't. Also, what's the S in SQL? It's structured, right? That's what it stands for. So it sort of depends on structured data already being there. So that's why I would really recommend taking a look at Spark as you're learning. And why Spark? I mean, my reasons are that it's very popular, it's very vital. It's also meaning it's alive and active. People are actively working on it. It's drawn a big consensus across the community. Now, maybe there may be people here who work with big data every day who might say, yeah, learn that, but also learn a few other things. So I'm just kind of giving you my introductory concept here. But I think it's a good one to start with. What's also neat about it is that, yeah, it's a framework for working with distributed data, really, not just big data. It's meant to work across all those different kinds of data sources, across all kinds of resource managers and environments. As I've been learning more about Spark, I've realized, like, oh, I could actually use this. I don't need a Hadoop cluster per se to use Spark. It's just a framework that has. It's actually written in Scala, but if you know some Python, you can easily interact with it. There's all kinds of wrappers for Python. So Yeah. So if I was going to give you some next steps as a SQL developer, how do I get started? What are my exact next steps? I would recommend this. First, you just sign up for that Databricks Community Edition. It's totally free. What they do is they stand you up a cluster, and I think if you don't use it for a couple of hours, they tear it down. So it's a very nice, low commitment. With the cloud things, I always worried that I'd like stand something up and then I'd forget and I'd leave it on and I'd get a bill at the end of the month like, oh no, I forgot to turn my cluster off, right? You don't have to worry about any of that with this. They also give you a really nice guide, the gentle introduction to Apache Spark. So it's very much step by step. You just type along with it, and you really, by the end, you start feeling like, I did it. I wrote Spark myself. There's a kind of a deeper dive there for data engineers. But the last thing I kind of urge you, ironically, is learn a lot more about the current, whatever database management system you use every day. Take a look under the hood to find out how that system really works. Because rather than just writing a query to it, you're never really going to be able to optimize until you kind of at least you pierce that layer of abstraction and get one or two layers deeper about what's really going on when I pass this command. You don't have to be a DBA, or you don't have to know everything that happens, but it might help you if you learn how does it handle these queries that I'm passing it. So I don't know if for you, if that's MySQL or if that's Cassandra or whatever, just pick up a book on it, or maybe just read a good blog series about what's really going on under the hood. I think for time's sake, I won't click on the Databricks thing, but it's easy, and hopefully we'll have the resources available for you there in the email. So in closing, I just kind of want to ask, do you really know data, or do you know a flavor of SQL? And it's okay to know a flavor of SQL. Probably every knowledge worker in today's economy should know SQL, actually. But you'll also probably want to start picking up skills on how do I get into that programmability layer of big data systems. As they become more common, I would expect almost every company will have some kind of distributed, unstructured data storage system. And if you can interact with that, then you'll be advantaged over some of your colleagues. People just also have a higher expectation of all of us technical people to be more DevOps, right? To be a little bit more multidimensional in our focus. So this will really help you. So here's my contact info. If I can ever help you, I build analytics systems and programs for companies, but mostly I just work with regular old data, just structured data. So thanks for your time. I appreciate the opportunity to speak to you. Should I try to feed this through?